Hello all, welcome to Module 6 Signals and Systems of Online STTP on Bloom's Taxonomy, Higher Order Thinking Skills in Electronics and Communication Engineering. This entire week we will be discussing about the gate problems and ISRO problems asked from Signals and Systems. This is Kalepriya, APEC, Savita Engineering College, here to present you a few problems on Signals and Systems. So this particular session, I've picked up Z transform. So all the basic problems on Z transform will be discussed at this entire session. So the first question being the Z transform f of Z of the function f of nt is equal to a power nt is. The given options are z by z minus at, z by z plus at, z by z minus a power minus t, and z by z plus a power minus t. This is a very basic Z transform question where you will have to apply the basic Z transform formula for the given x of n, and then find out the expression and find out the answer for this. So the basic Z transform expression is x of z is equal to summation n equal to minus infinity to plus infinity x of n z power minus n. So that is a basic Z transform expression. So Z transform of x of n, you can call it as x of z or f of z, however it is. So this will be summation n is equal to minus infinity to plus infinity x of n. So here we have given it as f of nt z power minus n. So basically we substitute the given expression and get an answer for this. So f of nt is given here as a power nt. So this we can have it as summation n equal to minus infinity to plus infinity. Instead of f of nt, we are substituting the given expression a power nt z power minus n. So any time you solve a Z transform expression, the basic point is you will have to take the n as common. I mean power n as common, however it is given. So here you find a power n and here you find the z power minus n. So then I'm just taking it as n common, power n common. So you will get it as a power t z power minus 1 the whole power n. Yeah. So this can be summarized as, so this is a power n. A power n can be written as 1 by 1 minus a. So 1 by 1 minus a in the sense a is a power t z power minus 1. So this is in terms of z inverse. You are making it as in terms of z. So what you'll have to do is you find a power t z inverse here. So bring the z to the denominator. It becomes a t by z. So when it becomes a t by z, take LCM and bring it as z by z minus a power t. So the option, I mean, the right answer here is option A. Option A, z by z minus a power t is your right option. Now, when Z transform is concerned, applying Z transform formulae and obtaining the Z transform of a particular function, whatever is given. So that is one sort. Second sort is you will have to discuss the ROC of the respective Z transform of the function, whatever you take here. So this problem will discuss about ROC. So the region of convergence of the Z transform of a unit step function is what they are asking here is for a unit step function, which is u of n, you will have to calculate the Z transform and hence its ROC, the region of convergence. So the region of convergence options are given as Z greater than 1, Z less than 1, only real part is greater than 0, or else the real part is less than 0. So the point here is given function is a unit step function. Unit step function, we define it as u of n. So u of n will exist only for n greater than 0, greater than or equal to 0. For n less than 0, the value is 0. So only for values of n greater than 0, u of n will exist. For n less than 0, u of n does not exist. So I've modified the given or the basic expression of Z transform as, generally you will have to write it as h of z, h of n, z power minus n equal to minus infinity to plus infinity. Since you're given x of z is a u of n, I mean the unit step function. So unit step function is going to exist only for n greater than or equal to 0. That is, from n equal to 0 to infinity, the value is 1. So for n less than 0, the value is 0. So I've shifted my what is it, the limit as n equal to 0 to infinity u of n z power minus n. So for 0 to infinity, the value of a unit step function is 1. So I'm substituting it as 1 z power minus n, summation n equal to 0 to infinity. So this simply goes as z power minus n. So what we are doing here is we are getting into summation of series formula. We want to use summation of series formula, so making it as z power minus n the whole power n. So n equal to 0 to infinity a power n. So our a is nothing but z power minus 1, a power n. The formula is 1 by 1 minus a. Otherwise, you can expand it as 1 plus a square plus a cube, etc. So summation n equal to 0 to infinity a power n is equal to 1 plus a square. So what is a? Z inverse. So I'm writing it as 1 by z plus a squared. A squared is z power minus 1 whole squared will be z power minus 2. So z power minus 2, writing it as 1 by z square plus next term will be a cube. 1 plus a squared plus a cube. A cube will be z power minus 3. So z power minus 3 is 1 by z cube. So it goes on 1 plus a square plus a cube plus a power 4, etc. to infinity. Now this can be summarized, or this can be written as 1 by 1 minus a. What is a here? Z inverse. So the answer is 1 by 1 minus a. A is z inverse. So that I've written it as 1 by z. So for a unit step function, the Z transform of a unit step function is 1 by 1 minus 1 by Z. Now, coming to ROC. Now, if you apply the summation of series expression, summation n equal to 0 to infinity a power n, the answer is 1 by 1 minus a. This series expression, the 1 by 1 minus a summation of series expression is valid only for a less than 1. So we take our ROC as a less than 1. What is a here? Z inverse. So a less than 1 means 1 by modulus of z less than 1. So the ROC can be otherwise written as z greater than 1. So the option, the answer here is first option, z greater than 1. So for a unit step function, we have taken Z transform, and hence we have also discussed the ROC to be Z greater than 1. So in general, for Z transform, when we apply Z transform, ROC will be considered as a circle of radius, whatever value is present here. Suppose Z greater than A means it will be circle of radius A. Z greater than 1 means it will be a circle of radius 1. So circle of radius 1 means minus 1 to plus 1, we will have to draw a circle. Suppose if it is given as z greater than 2 means, this is modulus of z greater than 2 in the sense, so that is minus z and plus z together. So you'll have to draw a circle of radius 2 that should cover minus 2 also. So that is how we'll have to draw the ROC. So the next question says, here again, the basic ROC is discussed, but it is of a different form. The Z transform of a system is given as h of z equal to z by z minus 0.2. That is given here. If the ROC is Z less than 0.2, then the impulse response of the system is actually what they are asking here is they have given you the Z transform of a particular function. ROC they have given. So what you will have to find out is you'll have to find out the inverse Z transform, meaning they have given you H of Z here. What they are asking you to find out is H of N. So you'll have to take inverse Z transform of the entire expression. So if you can see here, this is of the form Z by Z minus A, and Z is less than A. We will have to consider it like that. So here if you see, H of Z is equal to Z by Z minus 0.2. This is what is given here. This can be otherwise written in terms of Z inverse as 1 by 1 minus 0.2 is Z inverse, and the given ROC question it is given as modulus of Z less than 0.2. So for this, what we'll have to find out, we'll have to find out H of N, which is simply inverse Z transform of the given function. But when we actually find out the inverse Z transform, why ROC is actually used is to determine whether the given signal is a right-handed signal or a left-handed signal. This ROC is actually used, whether it comes under a causal or it comes under an anti-causal signal. So here you have given it as a Z less than 0.2. So the basic Z transform expression I have given here. If any signal is of the form minus a power n u of minus n minus 1, that is a left-sided signal. This is a left-sided signal. The Z transform of such a signal will be called as 1 by 1 minus A Z inverse. Now compare this expression with this expression, whatever we have got. 1 minus 1, 1 by 1 minus 0.2 is Z inverse. 1 by 1 minus A is Z inverse. Aren't they both same? So simply equate these both and find out what is this A. A is nothing but 0.2. So what is your H of N should be? A power minus A power N U of minus N minus 1. So H of N is given as your A is A is 0.2. So 0.2 power N U of minus N minus 1. So the from the given options, the option B is the right answer. So every time you have been asked problems like this to discuss about to find out Z transform or to find out inverse Z transform of these kind of formats, or if they are asking whether it falls under left sided or right sided if you're ROC, or if they ask you to find the ROC, the basic point is you will have to compare the given question with standard Z transforms like this, which is available in any signals and systems book, or you can Google it and see. We have a set of a few basic expressions. We have a set of a few basic functions for which Z transform is already known. You need not calculate these things, and you can just refer to that those expression. You refer to those formulas and then sort out the answer like this. Now, the next question is, yeah. Now, a sequence x of n with a z transform x of z is equal to z power 4 plus z squared minus 2 z plus 2 minus 3 z minus 4 is applied to a linear time variant system with an impulse response h of n is equal to 2 del of n minus 3, where del of n exists for n equal to 0. For other places, it is 0. What they are asking you to find is the output at n is equal to 4. The options given are minus 6, 0, 2, and minus 4. So from the given question, we could understand that x of z transform of a particular x of n is given. h of n is given, impulse response is given. They are asking you to find out the output at n is equal to 4. So now look at here. This is what is given in the question. X of z is equal to z power 4 plus z square minus 2z plus 2 minus 3z minus 4. This is what is given in the question. So here what you'll have to actually do is, h of n is also given in the question as 2 del of n minus 3. Now, delta function will exist only for n equal to 0. For other places, it is 0. Obtaining h of z first. Now, what we'll have to do is we'll have to calculate the output at n is equal to 4. Now, output in the sense, you will have to calculate y of n first of all. Then y of n we will have to calculate first. Output at n is equal to 4 is what they have asked you here. Output at n is equal to 4. So once you calculate y of n, you will have to calculate y of 4 by substituting n as 4. So this is what is the basic thing you will have to do here. Now what we are actually going to do here is, if you can look at this, y of z is equal to h of z into x of z. Meaning the transfer function h of z is equal to output by input, y of z by x of z. So that is the basic expression. Transfer function h of z is equal to y of z divided by x of z. So cross multiplying that, we have got y of z is equal to h of z into x of z. This is the basic expression we are going to use here for this problem. So once you calculate y of z, your next step is to take inverse z transform so that you will calculate y of n. So once you get y of n, we will substitute n as 4 and then we will calculate y of 4. So the point is very simple. So beginning, what we are actually, what we actually require is, to calculate y of z, we need h of z and we need x of z. Now, if you look at the question, x of z is already given in the question. H of n is given in the question. So what we need is x of z and h of z. So we need to calculate h of z from the given h of n. So applying z transform for this given del function, we will get it as twice of summation n is equal to 0 to infinity del of n minus 3 is at power minus n. So what is the basic z transform formula? X of z is equal to summation n equal to minus infinity to plus infinity x of n z power minus n. So instead of x of n, instead of h of n, we have substituted whatever del function they have given to you in the question. So on substituting, we will have to solve this. So how we will solve this? They have given it as del of n minus 3 z power minus n. So on substituting the given limits, this becomes 2 into z power minus 3. So once you get that, I think this is getting hidden. Yeah, now you can see here. 2 into z power minus 3. So how this del function got solved as 2 into z power minus 3. 2 is here. This summation n equal to 0 to infinity del function multiplied by z power minus n is nothing but z power minus 3. So how did we get this? Now look at this one. This is a property of z transform. Z transform of del of n minus k, shifting property. So if you have any function of this format, del of n minus k, if you take z transform of that, then the answer, the z transform of such a signal would be z power minus k. So whatever is the shifting point, to whatever number it is shifted, that becomes as z power minus k. That value is raised to z power minus. So here we have it as del of n minus 3. Look at this expression and this expression. Compare both. Z transform of del of n minus 3 is what they are asking you. So Z transform of del of n minus k is nothing but Z power minus k. What is given here? Del of n minus 3. So del of n minus 3 means Z power minus 3. So that is what we have written here as 2 into Z power minus 3. So we have x of z given in the question. We have obtained h of z by taking z transform of the del function. So what is your next step? Your next step here is to find out y of z. So what is y of z? H of z into x of z. H of z we have just obtained from the previous slide as 2 into z power minus 3. So this 2 z power minus 3 multiplied by your entire x of z. So x of z entire value we have put here. So 2 z power minus 3, if you substitute it inside, you get it as 2 multiplied by z. See, you have z power minus 3, then z power 4. So this will give you z. Then z power minus 3 into z power 2 will give you z power minus 1. Then z power minus 3 into minus 2z will give you minus 2 z power minus 2. Then z power minus 3 into 2 will give you 2z power minus 3. Then z power minus 3 into z power minus 4 will give you 3z power minus 7. So this will be your final y of z. Now after obtaining y of z, what we'll have to do, what they have asked you in the question is, you will have to calculate the output at n is equal to 4. So h is impulse response, x is input response. What is y? Output. So we'll have to calculate y of n first. So y of z we have here. So how do we obtain y of n? By taking exact inverse z transform of this. So how will you obtain exact inverse z transform of this y of z? And what you do is you keep this 2 as such. Now if you can look at here, z has become del of n plus 1. Z inverse has become del of n minus 1. I'll tell you how it is. Now again, minus 2 z power minus 2 has become del of n minus 2. Similarly, z power minus 3 has become del of n minus 3. Z power minus 7 has become del of n minus 7. How did this inverse z transform happen? Now, what formula is actually used here? If you can guess, you can post it in the chat box. We have just now discussed the formula. Look at here. Z transform of del of n minus k is z power minus k. So what is the inverse z transform of z power minus k? It should be del of n minus k, isn't it? Very simple words. Del of n minus 3 on z transform gives you z power minus 3. Z power minus 3 on inverse z transform will give you this same value, del of n minus 3. So the point is that you have z power, you have z, so z power is plus 1. So del of n plus 1. This is z inverse. Z power is minus 1. So del of n minus k. Inga vandu you have z power minus k. Z power minus 2. So del of n minus k. Del of n minus 2. Again you have z power minus k. Z power minus 3. So that becomes del of n minus k. Del of n minus 3. So similarly, z power minus 7 has become del of n minus 7. So every time you will have to make sure you memorize these standard formulas by heart, so that we need not sit and waste time thinking over like what we will have to do. Just apply the formula, get its z transform or get its inverse z transform. So when you're preparing, make sure you study the basic z transforms of all the basic functions existing, and also make sure you by heart the properties of z transform. By heart the statements of the properties of z transform, because this inverse z transform we have obtained using the shifting property. So the properties and the basic function z transform will actually serve the purpose for solving any signals and systems problem. So we have got a y of n here. So simple. What they have asked you is you will have to calculate the output at n is equal to 4. Simply substitute n as 4 here. So when you substitute everywhere n as 4, you get it as y of 4 is equal to 2 into del of 5 plus del of 3 minus del of 2 plus del of 1 minus 3 del of minus 3. If you can look at here, I've written the answer as y of 4 is equal to 0. Why did I write y of 4 is equal to 0? Go back to the question and refer. Your value of del of n is 1 for n is equal to 0. Other places, it is 0. Now, what n did we find out? 4. Look at here. do you only if there is del of 0 you can substitute 1. We don't have del of zeros here. We have numbers greater than 1. So then it is all zeros. So y of 4 is equal to 0. Now this expression y of z is equal to h of z into x of z. Otherwise, h of z equal to y by x, output by input. Now this is a basic expression which you'll have to remember for solving for the problems. So we have got the next question. This is again about the region of convergence. The region of convergence of a Z transform of the sequence must be pi by 6 power n u of n. Just a second. You are presenting. Okay. From current slide. Okay. The region of convergence Z transform of the sequence is given as 5 by 6 power n u of n minus 6 by 5 power n u of minus n minus 1 must be. So this, x of n is given to you. You will have to calculate region of convergence, ROC. So if you have to find out ROC, then you will have to find out Z transform of the given expression. So x of n is given. First find out x of z and then find out the ROC for it. Now the point here is we are not going to apply any formula or something like that. We will just compare it with the basic Z transforms. Now look at here. For the given sequence, we will have to find ROC of the Z transform. So what is the given sequence? 5 by 6 power n u of n minus 6 by 5 power n u of minus n minus 1. So this is a causal sequence. This is a non-causal sequence. This is a right-sided signal. This is a left-sided signal. Just take the first term of the sequence. What is the first term? 5 by 6 power n u of n. Now I told you I'm not going to apply any basic formulas or something like that. What I'm going to do is I have a basic set of Z transforms for a few basic signals. I'm just going to use it as formula and then apply it here. Now 5 by 6 power n u of n. So this is a right-handed signal, which is a causal signal. So this now just compare this with this. A power n u of n. Aren't these both the same? 5 by 6 power n u of n, a power n u of n. So if you have any signal like this, a power n u of n, if you want to take Z transform of this kind of signal, then Z transform is nothing but Z by Z minus a. Just now we have did it. Z by Z minus a. So a power n u of n, Z transform will give you Z by Z minus a. So if this is a right-sided signal, so right-sided signal means ROC should be written as Z greater than A. Left-sided signal means you will have to write it as Z less than A. This is right-sided signal. This is left-sided signal. So for right-sided signal, ROC should be written as Z greater than A. For left-sided, you should write it as Z less than A. So now, A is nothing but 5 by 6 power n. They are not asking you to calculate the Z transform. They are asking you only about the ROC. So I mentioned only that here. So ROC is Z modulus of Z greater than A. Modulus of Z greater than 5 by 6. So keep this aside. We will go to the next term, minus 6 by 5 power n u of minus n minus 1. So if you look at this term, minus 6 by 5 power n u of minus n minus 1, compare this with this basic signal, minus a power n u of minus n minus 1. So this is a left-sided signal, a non-causal signal. So this, if you have any signal like this, minus a power n u of minus n minus 1, Z transform of this signal is also Z by Z minus a. But the point is, the ROC, this is a left-sided signal. So Z less than A will be the ROC. So modulus of Z less than 6 by 5 we have written. So what are the two ROCs we have? One is Z greater than 5 by 6. Other one is Z less than 6 by 5. So one is greater than, the other one is lesser than. So I mean, we have find out two individual ROC, but what is the given sequence? Combination of these two functions are the sequence. So you'll have to combine the ROCs also. You have Z greater than 5 by 6 and you have Z less than 6 by 5. So the combined ROC should be written as, your ROC will lie between 5 by 6 and 6 by 5. So that is your final answer. Again, they have asked you ROC for the given sequence. So they have given a discrete time sequence. X of n is equal to 1 by 3 power n u of n minus 1 by 2 power n u of minus n minus 1. So what they are asking you, you will have to find out ROC for the given sequence. To find out ROC, what do you need? We'll have to take Z transform and then we will have to take the ROC. But what we are going to do here is, I'll just compare this with basic formulas and get the ROC directly. So this, if you can see, a power n u of n. This is a power n u of minus n minus 1. This is a right-sided signal. This is left-sided signal. So for right-sided signal, the ROC should be like Z greater than A. For left-sided signal, it should be Z less than A. Now come here. So we are taking Z transform. I mean, previously I've shown you by using the direct formulas and then we have concluded. You can do it by that way or you can do it by this way also. Now this will give you a detailed expression of how it is done. This is how a basic Z transform is done. X of Z is equal to summation n is equal to 0 to infinity 1 by 3 power n Z power minus n. What is basic Z transform formula? X of n Z power minus n. Summation n equal to 0 to infinity. So summation n equal to minus infinity to plus infinity is your basic Z transform limit. So here you have u of n, here you have u of minus n minus 1. So this is right sided, which is 0 to infinity. This is left sided, we have written as minus infinity to minus 1. And we have substituted both. So look at here. Now I've told you, like this is a power n Z power minus n, and this is a power n Z power minus n. Now this is a right-sided signal and this is a left-sided signal. So right-sided signal means it should be always Z greater than A. What is A? Z greater than 1 by 3. This second term is left-sided signal. Left-sided signal means what is ROC? Z less than A. So what is A here? 1 by 2. So Z less than A. So we have two ROCs, Z greater than 1 by 3, Z less than 1 by 3. So combine both the ROCs since both the functions are in combination. So your final answer will be Z greater than 1 by 3, Z less than 1 by 2. This can be consolidated as ROC of this particular function x of n lies anywhere between 1 by 3 and 1 by 2. So this is how your combined ROC formulas should be solved. Next, this is a very easy question. They are not asking you to calculate anything manually here. Simply, you'll have to guess the answer. The point here is, if the region of convergence x of n, x1 of n plus x2 of n is 1 by 3 modulus of z less than 2 by 3, then the region of convergence of x1 of n minus x2 of n includes. See, the point is very clear. What they are telling you here is, x1 of n and x2 of n are two different signals. Whatever that is, we are not bothered about that. These two are in addition. When two signals are, when such kind of signals are added together, this is the ROC they have obtained. Suppose if the same signals are into subtraction, so what will be the ROC? The point is, we'll take the previous expression itself. What is the previous expression? Previous question, 1 by 3 power n u of n minus 1 by 2 power n u of minus n minus 1. This is x1 of n, this is x2 of n. These two are in subtraction. I mean, a negative terms. So what is the ROC of this we have obtained? 1 by 3 less than z less than 1 by 2. Suppose if the same question we have plus here. So what will be the ROC? That is what they are asking you in this question. Answer is, both the ROCs will be the same, whether any two signals are in addition or they are into subtraction, the answer will be the same. So ROC of the given signal x1 of n plus x2 of n is 1 by 3 less than modulus of z less than 2 by 3. So ROC of x1 of n minus x2 of n, they have asked you, which is also the same, 1 by 3 less than z less than 2 by 3. I hope you're clear with this concept. Next, we have the other question. Consider the Z transform x of z equal to 5z square plus 4z minus 1 plus 3. I guess we have... there's no minus 1 here. I think I've... So consider the Z transform x of z is equal to 5z square plus 4z plus 3, where z lies between 0 to infinity. The Z transform of x of n is, you'll have to simply calculate the Z transform of this. So this we already know what it is. Z transform is given, you will have to find out inverse Z transform. So we are not going to do any big things. What we will do is we will just compare it with the given formula. You remember this one? See, if you can actually see here, x of z is equal to 5z square plus 4z inverse plus 3. Inverse Z transform we will have to take. Do you remember this point, del of n plus or minus a on Z transform gives you z power plus or minus a? Where did we see this expression? We saw it of different format. Look at here. Okay. You remember this one? Z transform of del of n minus k is equal to z power minus k. That is del of n minus 3. We should write it as z power minus 3. So z power minus 3 inverse Z transform will be del of n minus 3. So the same concept we have here too. So the same thing they have given here. What they have given you here is 5z square. So 5z square means how we should write it as a del of n plus k. So del of n plus 2. Next is 4z z inverse. This is z power minus k. Z power minus k means del of n minus k. So del of n minus 1. This is 3. 3 means how we should write it as 3 del of n. I mean, this is z power 0. So z power 0 means del of n plus 0. We will write it as del of n. So if you have been given any Z transforms like this, 5z square plus 4z inverse plus 3. If they have given it in terms of finite signals, then you can actually write it as, then you can simply apply the formula del of n minus k, z power minus k, and then find out the answer in this way. Next, we have two discrete systems with the impulse response h of n is equal to del of n minus 1 and h2 of n is equal to del of n minus 2. These two systems are connected in cascade. They are asking you to find out the overall impulse response of the cascaded system. Given our two systems impulse response, h1 of n, h2 of n, they both are connected in cascade. You'll have to calculate the overall impulse response of this particular cascaded system, and the options given are. So getting into the solution, what we'll have to do is, they have given that these two systems are connected in cascade. If any two systems are connected in cascade, then their transfer functions should be of this format. H of z is equal to h1 of z into h2 of z. So what is h1 of z? H1 of z is the Z transform of h1 of n. H2 of Z is Z transform of H2 of N. So simple. What you'll have to do is H1 of N is given to you, H2 of N is given to you. So from this, calculate H1 of Z and H2 of Z. What is H1 of N? Del of N minus 1. Del of N minus K. So del of N minus K. Z transform is Z power minus K. Just now we have seen. So del of N minus 1, we will write it as Z power minus 1. Again, H2 of N is equal to del of N minus 2, del of N minus K, which should be written as Z power minus K. So H2 of Z is Z power minus 2. So this is given that it is a cascaded system. Cascaded system means the transfer functions should be of this sort. The transfer functions are in multiplication, are multiplied together. So the overall transfer function could be written as h of z is equal to h1 of z into h2 of z. So multiply these both. Multiplying these both, you will get it as z power minus 1 into z power minus 2, which is nothing but z power minus 3. What they are asking you in the question, you will have to find out response of the cascaded system. What is h of z? Transfer function. Response is h of n. So h of z is equal to z power minus 3. They are asking you to calculate h of n. So apply inverse Z transform for this. This will become del of n minus 3. Same point, del of n minus k, Z power minus k. So inverse we are taking, which is del of n minus 3. So the answer is del of n minus 3. Next question. If x of n is equal to 1 by 3 power modulus of n minus 1 by 2 power n u of n, then the region of convergence ROC of its Z transform in the Z plane will be. Given our 4 options, kindly read those options. I guess which could be the answer for this particular question. I'll give you just a few seconds because we have been already doing ROC problems for a while, and I guess you should be able to. See, I'll give you a clue how you will have to solve this question. You have 1 by 3 power modulus n minus 1 by 2 power n u of n. So 1 by 2 power n u of n. U of n means it is a right-sided signal. Right-sided signal means how you should write the ROC as greater than or lesser than. ROC should be Z greater than A. What is A? 1 by 2. So definitely ROC for this one is Z greater than 1 by 2. But what about this one? 1 by 3 power modulus n. Modulus n. This could be split as plus n and minus n. So this 1 by 3 power modulus n will split into two functions. 1 by 3 power n, 1 by 3 power minus n. Accordingly, you will have to split the u of n as. So these are not two terms, but these are three terms. So write down the ROC for all the three terms. Consolidate the ROC and pick the answer from the given options. I'll give you a few seconds to wait for your answer. Post your answers in the chat box. Okay, listen. This is 1 by 3 power modulus n minus 1 by 2 power n u of n. So that is a given question for you. So this modulus n, we will have to split it as plus n and then minus n. Plus n means positive values, minus n means negative values. So for positive values, we are attributing u of n, and negative values will attribute u of minus n minus 1. Minus 1 by 2 power u of 1 by 2 power n u of n. So as I've told you, this is actually split into three different terms. So the basic expression Z transform of a power n u of n is what? Z by Z minus a. What is the ROC in this case? Z greater than A, because this is a right-sided signal, causal signal. Now, compare this with this one. 1 by 3 power n u of n. So this can be written as z by z minus 1 by 3. So this can be written as z greater than 1 by 3. Your third term minus 1 by 2 power n u of n. This is also a power n u of n. So what is your third term? Z by z minus 1 by 2 modulus of z greater than 1 by 2. But what we will have to check here is the second term. If you look at the second term, this is 1 by 3 power minus n u of minus n minus 1. So compare this with the basic formula what I've given here. B power minus n u of minus n minus 1 is equal to z by z minus b. ROC for such a signal, for such a left-sided signal should be modulus of z less than b. Now compare this basic signal Z transform with your second term. So the answer should be Z by Z minus 3. But then modulus of Z less than 3. So consolidating all the three ROCs. So consolidating all the three ROCs, one ROC we have arrived is Z greater than 1 by 3. Other ROC we have got is Z less than 3. The other one is Z greater than 1 by 2. Now if you can see here, it is actually given as 1 by 2 less than modulus of Z less than 3. So Z less than 3 they have applied here. But Z greater than, you have two options, 1 by 3 and 1 by 2. They have picked up 1 by 2, 1 by 3, 1 by 2. When you consolidate these two values, which is the highest value? 1 by 2 is the highest value. This is 1/3 and this is half. So definitely this is the greater value. So pick the greatest value as Z greater than. So this will be 1 by 2 less than modulus of Z less than 3. So your ROC is a circle, is a circle which is having the values between 1 by 2 and 3. Yeah, this would be the last question for this session because we just have 5 more minutes to end. Now look at this question. What they've given you here is the Z transform of a real exponential signal x of nt equal to a power n, where nt is greater than 0, 0 when nt value is less than 0 and a greater than 0. So, and we have a few options given here. We will have to find out the Z transform for this given question. Read the question carefully. We will just switch on to the solution part. So the given sequence can be considered of the format a power n. So if it is of the sort a power n, just a second. Yeah. The given signal, you can consider it as a power n signal. So if it is of a power n, they have already given it as a greater than 0. A greater than 0 means definitely it should be a right-sided signal. So a power n u of n, it could be of that sort. So if it is a right-sided signal, then the basic Z transform, whatever we have seen is Z by Z minus a, modulus of Z greater than a. This is the basic Z transform. So whatever we have here, what is your a here? The same thing we are applying here and we are getting it as 1 by 1 minus a Z inverse. This is for Z. In terms of Z inverse, we can write it as 1 by 1 minus a Z inverse, where Z is greater than a. So comparing that, we observe your answer to be B, this one. This we are picking up as the answer for this basic question. I hope you understood the point behind this. This is given as a power n. So a power n, we are, and it is given as it is a greater than 0. So from the value a greater than 0, we have understood that this is a right-sided signal, and the function given is a power n. So we are comparing this with a power n u of n. A power n u of n means your basic Z transform is Z by Z minus A, and your ROC is Z greater than A. But if you look at the options, they have given it in Z inverse. So in terms of Z inverse, this can actually be written as 1 by 1 minus A is Z inverse, Z greater than A. So your answer is B for this case. So with this, yeah, so with this, we are getting into the end of this session. We have solved gay problems from signals and systems, and today I've taken all the topics, I mean all the problems concerned from Z transform topic. I hope I've covered a bit of it. Tomorrow, please get back to the same time at 11 a.m. In the morning. We will see remaining signals and systems Z transform problems and a few others. Thank you all for attending this session. I hope you would have got to know something regarding signals and systems. Even those who don't know signals and systems, I hope this would serve the purpose. They will get to know how they have to prepare while preparing for the exams. So the session is officially over. If you have any